In this example, we are going to set up a Pickmaster application with 2 robots. The robots shall pick incoming items from a first conveyor. They shall place the items in containers on a second conveyor. Incoming items on the first conveyor shall be detected with a camera. Incoming containers on the second conveyor shall be detected with an I/O sensor. The starting point in this example is a Robot Studio station with 2 already created picker robots that have been placed in suitable positions. Both robot systems have been created in the Robot Studio Home tab. We switch to the Add-in tab and click on the Pickmaster Sim button. The Pickmaster tab opens up. The ribbon area on top now displays the picking functions. When a Pickmaster application shall be set up from scratch, the workflow goes from left to right in the ribbon. First, in the line group to the left, the application hardware, like conveyors and cameras, are set up. Second, in the job group next to the line group, items and containers that shall be handled by the Pickmaster application are set up. Third, in the simulation group to the right of the job group, a simulation of the created application can be launched and managed. Let's start to set up the application. Starting from the very left, we add a picking controller for the first robot. We also add a picking controller for the second robot. Next we create the picking tools that shall be used to grip the items. We create one picking tool for the first robot, and another one for the second robot. Next, we add a first conveyor where the robots shall pick items. We add a second conveyor where items shall be placed in containers. We reduce the width of the second conveyor slightly compared to the first conveyor. We adjust the positions of the both conveyors to be within picking and placing range for the robots. Next, we add work areas on the conveyors where items shall be picked and placed by the robots. We add a pick work area for the first robot on the first conveyor. We also add a place work area for the first robot on the second conveyor. In the same way, we add pick work area for the second robot, and a place work area for the second robot. Next, we add a camera. The camera is attached to the first conveyor. We also add an I/O sensor on the second conveyor. The next step is to create conveyor flow handlers. A flow handler defines how an incoming flow of objects shall be detected and which work areas that shall be used for handling them. We add a conveyor flow handler to handle incoming items on the first conveyor. The camera is selected to be used for detecting the items. Both work areas on the first conveyor are selected for picking. We also add a flow handler to handle incoming containers on the second conveyor. We select the I/O sensor for item detection. Both work areas on the second conveyor are selected for placing. The next step is to create items and containers and define how the picking application shall handle them. We click on the Item Container button. One default container is already created, we will use that one. We add a cylinder-shaped item. The next step is to create a container pattern. A container pattern defines how items are to be placed in a container. We click on the Container Patterns button. One empty default container pattern is already defined. We use that and add the created cylinder item to it. We continue to the Layout tab and select one of the suggested layouts. Next we add this layout as a single layer in the container pattern. The next step is to create a job. A job defines how incoming items and container patterns shall be handled by the application. We click on the Add Job button. First we add the cylinder item to the job and select that it shall be detected by the camera, be picked on the two pick work areas and placed on the two place work areas. Next we add the container pattern and select that it shall be detected by the I/O sensor on the place conveyor. The warning triangles in the tree view to the left indicates that the conveyor work areas needs to be calibrated. This is done by simply clicking the Calibrate button. The controllers are restarted to enable the new calibration. The warning triangles disappear after the restart. The picking application is now prepared for starting a simulation. A simulation is started by pressing on the Start button. An operator's interface can be launched to monitor and tune the simulation. We can monitor the pick rate of the robots and comprehensive picking statistics. It is also possible to tune the running simulation, for instance increase the speed of the second conveyor,